Standards and How They Impact Cable Assembly Designs webinar. My name is Kendall Paradise, and I just wanted to give you an introduction before we get started. I wanted to let you all know that you'll be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel located in the webinar control panel, and we will try to get to them all at the end of our presentation. Also, we are recording this webinar, and we'll be posting both the recording and slides on our website and YouTube channel. Our presenter today is Brian Morissette, our Cable Assembly Product Manager. Brian has over 32 years experience working in electronics manufacturing. He directs and assists in sales for all of our cable opportunities, working directly with customers to recommend the appropriate cable specs for each application. Brian oversees the design and manufacturing of cable assemblies, working out any issues to ensure quality service and products. Prior to coming to EPIC, Brian has held positions in both business development and manufacturing, which has allowed him to be so successful. With that, I will turn it over to Brian.
Thank you, Kendall. First, I'd like to thank everyone for being a part of our webinar today. As we move forward, we'll be looking at the impact of standards on the design of assemblies and the various actions we can employ to ensure we meet the respective standards that a customer would call for. To begin this webinar, we'll explain the definitions of what a standard is, what a code is, what recommended practices are, and how each of these have an impact on assembly design. We'll also talk about the levels of standards and codes and what the impact each has that we need to address when we design an assembly. Those types of issues that need to be addressed would be material-centric, product-centric, safety-centric, and customer-centric issues. I'll also look at standards from a global standpoint and the impact they are having on the designs we're currently creating for assemblies. And as a capstone, we'll look at several examples of standards that we need to consider from both a manufacturer standpoint, but also a user standpoint. So we look at this and we say, what are the guiding principles of a standard? A standard really should show a relationship to design for manufacturability and design for the environment. It should minimize time to market. It should contain simple language. It should just include spec information. It should not inhibit innovation. It shouldn't increase time to market. It should not increase any type of cycle time. And again, these are guiding principles that were published by the IPC organization, the Executive Committee, in 1995. And they are a good set of guidelines that we go by to be able to develop a product that meets the needs of the customer. So the basic question, what is a standard? A standard is something that is widely accepted as a basis for comparison. In the context of our discussions today, we'll look at a standard as a vehicle that allows the interoperability and commonality of products from various producers to be able to be compatible with other producers' products. The use of a standard is voluntary, and the implementation of a standard doesn't interfere with that there is only one way that a product can be designed. A major concern is the number of its standards in existence today. It is not uncommon to have competing standards cause confusion and duplication of effort instead of adding to the usefulness of a product. As Andrew Tannenbaum noted, the nice thing about standards is that there are so many of them to choose from. When we design a product, there oftentimes can be much confusion about which standard rules over another. For instance, if you have a performance standard that has conflicting information to a customer standard, then we have to decide which one will take precedent over the other. Another issue we'll talk about is what is a code? Much like a standard, the code sets in place guidelines that should be adhered to provide a basis to which products or practices can be compared. Unlike a standard, though, a code can either be complied with voluntarily or it can be mandated by law for compliance. Probably the best example of a code that everyone pretty much understands here in the United States is the National Electric Code. The NEC is a published document that is generally accepted as a consensus for the correct methods of production and installation of any devices relating to anything electrical. That is the go-to guidelines for all building codes everywhere in the United States. Another issue that we need to deal with are what are recommended practices. Recommended practice is just a method or a technique that's consistently shown satisfactory results when it's employed. In the design and manufacture of cable assemblies, there are many practices that have been used successfully for years, but do not fall into a standard or a code arena. For instance, the proper way to handle and store cables and assemblies that use silver-plated conductors is a recommended practice issued by SEA International. This document details the methods that should be used during manufacture and storage of both cables and assemblies to avoid corrosion, or in the industry it's called red clay. Common practices is not considered a fixed rule, and it is these practices that are developed using sound judgment from an engineering standpoint. From a material-centric standpoint, there are many, many standards that are used in the manufacture of both cables and assemblies. These are the standards that are used from the start of the manufacturing process, where the copper bars are turned into copper rods, which then go into copper strands and copper wire. The ASTM standards tell us the processes and the results that are required when producing that copper wire. The standards dictate the diameters of the strands of copper, the composition of any plating used on the copper, and the thickness needed for plating when it is applied, the lay or twist needed for individual strands of a conductor, and the proper test methods to test the copper too, and as well as packaging and handling of the wire and whatnot once it's made. Arguably, the most important of all the standards and codes that are involved in the production of cable assemblies are those related to product safety. Every organization that develops these standards and codes has the greater well-being of the general population in mind when they create a document. And the document that is created usually is created after some incident happens. Those instances are usually tragedies, or they could be results of studies that show there's a need to improve some aspect of the process or the assembly. The majority of the safety standards written in North America are done so by UL and CSA, or a combination of both. In the past, UL was mainly focused on product safety for the United States, and CSA was mainly focused on the product safety for Canada. With those two in mind, it caused a lot of conflict between the two organizations and confusion for the manufacturers that were using the standards at that point to decide what they wanted to make. Based on that, both UL and CSA decided to get together and have begun to issue harmonized standards that cover the safety requirements of both the United States and of Canada. What this does, it allows one document to be created and used in both countries, and both companies accept the results of that document. Though both UL and CSA have issued documents relating to the manufacture and installation of assemblies, it's a responsibility of the local authorities that have jurisdiction where the installation happens to enforce the standard of code. That authority could be a local fire marshal, he could be the local building inspector, he could be the local city code inspector, or even the local building owner. To meet the requirements of UL and CSA, products need to be tested by third-party laboratories. These labs are accredited by OSHA as having testing capabilities that provide truthful and consistent results. Once the product is tested and successfully passes the required test, the manufacturer or producer of the product can label their product with the testing lab's mark and logo. And by using the markings, the manufacturer of the product it's applied to certifies that the product meets all requirements stated in the respective UL or CSA code, And in most instances, that mark is all that's needed at the local level to be accepted by those authorities having jurisdictions. There are other organizations in the United States that also produce safety enhanced type of products. Some of those being ASTM, IEEE, NESC is part of the IEEE organization, ICEA. So there's a whole litany of other organizations that do produce guidelines for safety of products in North America. Fire and building codes across the United States were implemented shortly after the Coconut Grove fire in Boston on November 28, 1942. In that instance, there were 492 people who died in the fire because of the lack of exits in the building, the lack of occupancy limits, the lack of the use of highly flammable decorations and components of the building, and the lack of enforcement for the codes for the buildings. The building was listed as being able to handle 460 people maximum. At the time of the fire, there were more than 1,000 people in the building. In that particular building, the exits had been bolted shut, bricked over, because of both prohibition, because the owner of the building at that time was afraid that the patrons were going to skip out without paying the tabs. The only operable door was a rotating door. When the fire broke out, that soon became not operational because of the amount of people trying to get out of the way. Because of the fire, occupancy laws were implemented across the country, and now, based on that, they're also being enforced. Codes were established to dictate what types of materials could be used in the construction of a building, and they were also dictated as to what type of decorations could be used inside the building. And that really is the beginning of the building codes as we know them today. There are some performance codes out there that we need to be concerned with, performance-centric verification codes. And that really is not set or enforced by authorities having jurisdiction, mainly because it doesn't impact any type of human safety. Those performance-centric codes that we use really intended to provide the end users confidence that when they buy a product, it is going to perform as they expected it to do when they ordered it. The performance-centric verifications that we do really ensures interoperability and what the expected performance would be, meaning that you could buy a product from ourselves or from any competitor and be able to plug it into a system, and based around the performance-centric verification, it will perform the way it was designed. And some of the performance standards that we comply to are put out by ANSI, being the TIA 568. ISO puts some out. IEEE puts some out. So again, more levels of verification that we need to be aware of when we build an assembly. Some standards specify electrical characteristics that assemblies must meet to succeed. These electrical requirements, not required by the authority having jurisdiction, but they also have to meet or exceed the standards published by certain organizations, as I mentioned before, TIA, EIA, ISO. And we test all of the products for those performance capabilities once the assembly is completed. The assemblies still have to meet all the safety requirements set by UL and CSA, and those requirements are really based around the environment the cable is going to be installed in. But the performance is usually measured, if we have to submit the product to outside labs, nationally registered testing laboratories. And currently there are 15 different facilities recognized by OSHA that are worldwide that we could use to do the testing. And they'll test our assemblies for either environmental, they'll test them for safety, They'll test it for electrical, whichever we really want to do. But when we build an assembly, we sometimes need to utilize those labs to be able to test the products to guarantee to our customers that the product is going to perform to the standard that they're going to use the product in. Some standards also can be set by the customer. Customer-specific issues may consist of any number of concerns that the customer may have. These could entail matching a specific color for the jacket, the connector body, or the strainer lead. The color is usually specified by a Munsell color, a Pantone number, an RAL number, or sometimes we'll get a sample of the color on a swatch of the component the assembly will be used in. Some customers request that their corporate logos be included in any overmolds that we put on the cable. This could entail specific characters, fonts, scripts, anything that really is pertinent to that customer. But all these customer-specific standards are just another level of concern that we as an assembly producer need to be aware of up front. The reality in the industry is that all standards are not always adhered to. There have been several instances lately where products produced outside of North America have been found not to meet the safety requirements set by UL or CSA. The products that were found were marked properly, and based on all the documentation that was supplied with those assemblies, they were supposedly meeting all the relevant codes. When there was a follow-on test conducted, which UL sometimes does spontaneously in our factory, it's found that the assembly had been made with a cable that did not meet the flammability requirements of the style printed on the jacket. Based on that, increased testing was conducted, and it was found that there had been many instances, not only with ourselves but with other companies as well, where the wrong compounds had been used in the components of the assembly, and those compounds didn't come close to meeting the flammability tests required by UL. UL standards and codes really help purchasers select the most appropriate product for their needs based on the environment that the assembly is going to be used in. If non-compliant products are used, suppliers such as ourselves and contractors that install expose themselves to liability for product failure and resulting safety issues down the road. Over the past few years, as the world is getting smaller, we're utilizing more offshore facilities and bringing them up to speed. There's been a trend towards international harmonization of codes. Those actually include all the standards and recommended practices, codes, and anything that's relevant to installing an assembly in an application. Historically, the codes and standards established in the U.S. were globally accepted. But with the emergence of the European Union and other regional trade organizations, there's been a wide adoption of ISO and IEEE standards that have become more common. The regional trade groups that are developing are setting their own codes and standards based on occurrences of loss of life or property or needs based on their regional geographics, which they really should do. The establishment of the codes, standards, can be done really by any industry or manufacturing group, engineering or professional societies, or even government agencies. As the world economies are growing, they're realizing the need for both localized and global standard establishment to meet their particular needs. We'll look now at some specific standards and detail what the requirement of each standard is. TIA, which is the Telecommunications Industry Association, oversees the development of standards used in the cabling of buildings, be them commercial buildings, public buildings, any type of wiring that's going to be used inside of a building, the TIA will oversee. Will mainly used for commercial buildings. The performance criteria of those products they oversee are also used in private residences in homes. The intent of the TIA is really to develop a universal wiring standard to be able to support multi-vendors products and to support varying environments with just one product. The TIA standards are widely adopted and considered really the global standard for data system design. The TIA standards are live documents and do get revised as technology advances. For instance, the speed that we're pushing down some of the category cables that are installed in the backbone of a building has increased, which really has necessitated a better performing cable to be used. That cable, which turned out to be a 10 gigabit Ethernet, came in to be a larger cable than it was replacing. So the band radiuses in the standard need to be revised and changed. And because it is a live document, the committee, the TIA committee, did meet and they did revise that band radius. Under the TIA umbrella is a standard used to guide the structured cabling market, which would be TIA 568A. That standard covers all the assembly used for the connection of computer networks, such as Cat5, Cat5e, Cat6, Cat7, and there's a proposal out there right now being discussed for a Cat8 standard. To ensure standardization of the components, the 568 standard details and specifies the performance characteristics for the various levels of each of those, such as Cat5 and Cat6. They specify the assembly test requirements that we have to meet to be able to sell the product. They specify the cable types that need to be used based around the application, be it a backbone cable or a drop type of cable. They specify the conductor size needed to support the maximum length that the assemblies will see. They specify the color code that the cable has to have for termination, and they specify the connector types that need to be used. All the components, those various components are specified to ensure that products from various vendors are going to be compatible with each other, so that any product from any vendor can be installed in the system, and that system will perform as it was designed. In the medical assembly arena, there's a high degree of standards that need to be complied with. Medical devices are highly precise and must work in all kinds of environments, really not seen in other industries. The assemblies produced for the medical world have to be able to withstand vibration, exposure to all kinds of liquids, and be able to withstand being sterilized over and over many, many times. These requirements make the assemblies used for medical applications more restricting than commercial off-the-shelf items. The medical industry is still very much a tethered world. Wireless hasn't impacted them as much as it has other industries. And as such, they still consume a high amount of assemblies. Because of the applications, though, medical assemblies are held to a much higher standard than assemblies used in the Datacomm world or the industrial world. Concerns around electrical performance and patient safety are really the critical concerns when building medical assemblies. From an electrical standpoint, performance is needed to ensure no false signals are transmitted over the assembly, or that the assembly transmits all information in a timely manner that's sent down there. One of the highest concerns when we're building a medical assembly is the issue of triboelectric noise. Now, triboelectric noise is the result of two components inside an assembly, be it conductors or a conductor and a shield, rubbing against each other and producing some type of noise or static that will cause false signals to be transmitted or cause a transmitted signal to be wiped out because of the noise. Medical assemblies need to be fully tested to make sure they're electrically sound. Due to cleanliness, packaging and manufacturing of assemblies is really a highly controlled area. During shipment or manufacturing, contaminants like dirt, grease, or really any other type of contaminant need to be eliminated. So the use of clean rooms for manufacture in most instances is a necessity. Blister packaging is frequently used on medical assemblies to seal the assemblies from those contaminants so nothing is picked up during the transit or storage. So I mentioned that the medical industry is really highly regulated by the use of standards. The manufacture of cable assemblies is not. The relevant standard for medical is an ANSI AAMI 53 standard, and that was developed with the primary purpose of promoting patient safety many, many years ago. The standard originally wanted to prevent the connection of patient leads to a power source and therefore shocking the patient. Before the standard was put out, there was a lot of patient leads that were connected to AC supply, and they were causing more harm than they were doing good to a patient. Based on that, the standard defines how the cable and the lead wires should be connected inside of inside of an assembly. Specified in the document are dimensions of the pins and sockets, the amount of setback interconnector the pins and sockets should be. And what they're basically doing is making a foolproof or touch-proof connection that is going to be used so the patient is not harmed in any way, shape, form, or manner. The ANSI 53 standard also details the correct methods to clean the assemblies and the machines they're connected to, the correct way to disinfect the components, the various ways to sterilize the products, and for how long they should be exposed to the sterilization process. Also included in the spec are the minimum performance criteria for some of the electrical characteristics to prevent or diminish any triboelectric noise. It also specifies the test methods that we need to utilize to find out how much triboelectric noise our assembly is really creating. So the standard 53 was developed to address the cables used in ECG equipment and lead wires. It's commonly used today as a base to establish the performance criteria of other medical assembly applications. Where the medical industry lacks for standards dealing with product-related issues, they more than make up for standards dealing with the manufacture of medical-related parts. Standards have been developed to control the design of medical devices, for the quality system used in the production of medical devices. Virtually every aspect of the cycle is watched over from a medical standpoint. There are also standards that harmonize laws relating to medical devices within the EU. Standard ISO 14698 really details how to control biocontaminants in the production of the medical devices. And in that standard, it specifies the characteristics of varying levels of clean rooms based around the ultimate use of that medical assembly. In the Datacomm industry, there are quite a few standards that really need to be dealt with, of which one of those is really dictated by the InfiniBand industry. That standard was developed by the InfiniBand Trade Association and details the communication network, communications link, used in most high-speed storage systems in supercomputers. The InfiniBand Trade Association compiles a list of integrators that produce products that they have tested and approved for use in the InfiniBand systems. The testing of those products is conducted by the InfiniBand Trade Association under their guidelines and in their controlled labs. The performance of the components is measured during the testing. And if you pass the minimal performance of the InfiniBand standard, you're added to the integrators list. Potential purchasers of InfiniBand products can go to that integrators list and choose from a litany of vendors who have compliant products to the InfiniBand standard. The testing of those products, the InfiniBand products is done based on throughput of the components, such as SDR, a DDR, or QDR, and each one of those would be a single data rate, a double data rate, a quad data rate. Depending on the performance characteristic, that's what you need to have your product tested to. And if you pass, you'll be listed on the integrators page for those products. In the industrial marketplace, standards are created to ensure products can really withstand the rigors of the manufacturing floor. One of those standards, DeviceNet, was developed by the ODVA, the Open DeviceNet Vendors Association. The ODVA is really a global trade and standard development organization, and as such, develops standards that are globally based. The DeviceNet standard details both trunk and drop cables that are used in most industrial networking applications today. These cables and assemblies comprise the communication network between industrial controllers and I/O devices at local machines or robotics. Products to be used in those applications need to be certified to the ODVA standard, and they must meet the electrical performance criteria of that standard as well. Other aspects that we need to meet would be minimum flux tests, abrasion resistance, chemical resistance, as well as the electrical testing. And as I mentioned before, the ODVA is a global standard and is currently supported by over 700 vendors worldwide. One of the biggest issue we have is when we deal with the government. When dealing with the various levels of government, there are standards and regulations galore that we need to comply with. From a high level, regulations such as EAR and ITAR really dictate how products are produced and who can produce them, as well as dictating who the parts can be shipped to. The control of materials and processes are handled by the United States military standards, or better known as defense standards, military standards, mil standards, or mil specs. Those standards and specifications achieve standardizations of the products that the government purchases by detailing materials that are used to build the products, as well as the processes to use when building them. Adherence to the various specs when building products for the government is critical. Non-compliance is not an option. In conclusion, by referencing standards that need to be met when asking for or ordering an assembly, simplifies the entire process. The producer of an assembly, such as ourselves, can associate with the standard, and that association will specify in most cases exactly what raw materials need to be used, the electrical characteristics that the assembly needs to be tested to and meet or exceed, as well as any other characteristics such as chemical resistance or being able to be sterilized type of deal. And when you deal with a supplier familiar with those standards and directives, it will ensure that an assembly will be produced that complies with the standards that you're most interested in. Standards, as I mentioned before, are living documents, and they're constantly being reviewed and changed. So for someone like ourselves to keep up with those changes is an imperative that we do on a daily basis.
Thank you, Brian. I just want to take a moment while Brian's reviewing some of the questions that came in to go through an overview of EPIC. In addition to our cable assembly products, we offer a variety of other custom build-to-print products, including battery packs, flex and rigid flex printed circuit boards, user interfaces, fans and motors, as well as printed circuit boards. For each of these products, we have a specific product manager like Brian who is dedicated to helping our customers from design and startup projects through production. In addition to having a product manager, we have a location for each of these products. For battery pack and power management, that product is managed out of our Denver, Colorado Technical Center. for our user interface and cable assemblies is managed at our Largo, Florida facility. For fans and motors, our technical center is in Wales in the UK and in New Bedford, Massachusetts. For our printed circuit boards is in New Bedford, Massachusetts and Shenzhen, China. Our flex and rigid flex technical center is in Toronto, Canada. And cable assemblies is here in New Bedford as well as in Largo, Florida. Our engineering and design teams, as well as all of our product managers, are always ready to help our customers create world-class and cost-effective product solutions over all these variety of products. So with that, I'll turn it back over to Brian, who's going to go through some of the questions.
Well, thank you, Kendall. Some of the questions that have come in, some interesting questions. One that came in asks, in my description of the ODVA DeviceNet technology, I mentioned trunk and drop cables. And what the attendee wanted to know, could I explain what these are and what the difference is between them? Interesting question. A trunk cable is really the cable or the backbone cable that would run around the building. And from that, you would have drop cables that are terminated to the trunk cable by using an IDC type of connector. Now, the drop cable would go from the trunk cable down to the individual machines to be able to control any type of characteristic that machine may need, be it a flow control or be it robotics, whether it be instructions on how to operate or that type of stuff. But they use IDC connectors on the trunk cable, so you don't need to cut the cable and re-splice it. The connector is keyed, so it can only be wired in one way. And when it's applied, the IDC terminations will pierce the respective conductors they need to be able to provide all the contact with the drop cables. Another question that came in, that even though the NEC code here in the United States tells us that we should be used, a product should be used in a given environment, that I mentioned that the local authorities had the final say in what is to be used. Is that true? Yes, it is. Local authorities have the final say on what products can be installed inside of a building. And that building can be anything from a home to a public building to a business to a manufacturing floor. So the local building inspector, the local building authority, it could be anyone on the local level, does have the final say on what products to be used, and they could enforce that a product of a higher flammability rating be used in lieu of what the NEC code says. I very, very seldom have heard that they'll let a product of a lesser flammability rating be used. In most instances, it's because they enforce a higher flammability rating. Another question came in. I find it interesting that the various standards are developed by committees. Can anyone join these committees? My answer would be, in most instances, yes, provided that the person who wants to join a respective committee deals in products or deals in the industry that committee represents. For instance, if you're in the Datacomm industry, they may not let you join a committee. In the industrial sector, you won't have anything to contribute to that. But if you're a committee that you're interested in joining delves in your arena, most people can join the committee. There'll be dues, there'll be bi-monthly meetings that you'll need to go to, but most people can join, and you can become voting members to help direct how those standards are written. That's about all the questions I have in at this time. If there's any other questions as you go forward that you'd like to submit, by all means do so, and we will get back to you and answer those as soon as we can. I'd like to thank everyone for attending the webinar, and please, in the future, as webinars come up, feel free to join and listen in on what we have to say. Again, thank you.